Hello, my name is Martin Smith, and I'm here to talk about timing of a photon. This all started with the double slit experiment, and, well, also along the lines of polarization. The only way I can get them to actually work is if photons are timed upon their release. And in order for them to be timed upon their release, it means that other things have timing in them that we don't realize or don't even think about as having timing. A lot of people don't even realize that there is a big conundrum with polarization. It works nice provided we look at it as the wave in polarization being a plane wave, stating that the wave stays in one plane. The hard part is that we all know that photons have spin. Some people are looking at the polarization situation and saying, well, we have a conundrum, therefore photons don't have spin. That is a possibility. This is what I'm doing is pure speculation. And I'm just going to go over it. I'm speculating that protons, neutrons, and electrons all have their own resonance. That means protons are very small, and for the center core of two parts of a proton to be going in the speed of light, and this is speculation on top of speculation, the frequency of that requirement would be very fast. Neutrons, going with the vortex model, neutrons would have it would take the frequency of the protons and neutrons and put them together, because it would be locking together two positive and two negative vortexes. So neutrons would have their own frequency, and electrons, being much larger, much lighter weight, would also have their own frequency, and these frequencies would be forced to not compete with each other. So since it's the same media that's vibrating, the competition for those vibrations, or for the synchronization of the vibrations, one vibrational synchronization cannot interfere with another. Then we have the vibration of free electrons, and that one comes with a story by itself. One of my first machine shop jobs, and this is one story I can talk about because it's over 20 years ago. Gilbarco, a gas pump company, came to the owner of the shop with a project. They couldn't get the flatness of the pump housings done right, and they were doing cast iron. We were very proficient in cast iron, and in getting it flat, we were doing work for Cummins diesel, and those had to have flatness within 0.3 of a thousandth of an inch. Well, for them to be happy about it anyway. And the owner took it on, and he knew about that. He knew about Gilbarco anyway. So what happens is Gilbarco has hundreds of engineers and hundreds of machinists working for him. And the problem with that is that all these engineers and all the machinists, they all approach things the same way. And so we got this cast iron, and the big issue with this thing is we were only cutting one side, and we'd get it down to within a 6-inch diameter. We would get it down to about 0.7 of a thousandth flatness, and that was the best we could do on it. And we were using CBN diamond facing tools for finishing it. And like I said, we were the best. We had grippers on our chuck jaws. We turned the pressure down as low as we could on it for the finishing, or to get a good finish, because we also had to face it. and we'd read them right, send them out, and they'd come back to us a couple days later, and the inspector even marked them marked the parts so that when we got them back, we reread them and they weren't right anymore. And I remembered something that I read years before that about electrons in metal. When they're hot, the spin of the electron, it randomly orientates, and then when it cools down and solidifies, those orientations, they line up with the atoms next to each other, but only with a clump of about 30. So over time, these 30, they'll eventually shift into place so that they have balance, so the magnetic fields balance out with the rest of the atoms around it. Not necessarily making it magnetic, but a balance that relieves the pressure on it. Because what happens is the outside of the part cools faster than the inside, so that when the inside does cool, it creates pressure on it. And that pressure is what gives the cast iron a lot of its strength. So when you cut one face off of it, it holds steady. And I asked the two people in charge of that project on my company, and I put this to them like that. And my question was, how long does it take for that, for those electromagnetic fields to actually swap? Because it warps over time. And from there, they came up with a procedure to rough the part out, put it on a shelf for 24 hours, bring it back, and then finish it. And after we did that, we initially had it to about 5 to 7/10 of a thousandths flatness, and it apparently changed within the time it took to get to the machine to the inspectors of about 2/10. And then we set it aside again for another 48 hours to remeasure it, and that test lot of 200 parts usually went from between 7 and 9/10 of a thousandths, but it was under a thousandth of an inch flatness through the whole 6-inch part. So we sent them off, and they loved it, and they said, "Oh, we want to take a look at your shop to see how you're doing it." And Neil pretty much told them no. And a few months later, they kept insisting, so we put all their work up so they couldn't see what we're doing. A year later, Neil finally gave in and let them walk through the shop, and the very next day, they pulled all their work from us. So this is one of the reasons why I don't talk about stuff that I do at work, is because, one, I can lose the job for the company by talking about it. 2, I can be sued for giving away company secrets. And 3, I could be put in Gitmo for giving away military secrets. Because we get blueprints, they come from engineering firms, and a lot of those firms are really military firms that are just getting parts from random shops so that nobody knows what's going on and nobody knows what they're making. So if you don't hear me talk about what I do at work, well, that's the reason why. And this particular thing about the free electrons also comes back to the idea of how strong and how forceful the synchronization would be between protons or electrons moving around the center of the atom. So even though electrons are moving, protons are actually vibrating a little bit too. Electrons don't have a lot of weight or don't have a lot of inertial mass. I'm not even too sure if they have gravity, but they are rotating around each other. So what we're doing is, or what I'm doing, me, myself, and I, for the we part, I'm saying that we have a lot of protons in a lattice and a whole lot of electrons going around those lattice, and those electrons are actually traveling around in synchronized effect. And that synchronization is electromagnetic. That electromagnetic effect does move at the speed of light. So after you get about 30 atoms out, you're going to start having interference with a magnetic. By the time that magnetic interference gets 30 out, one, it's extremely weak because it's 1 over r squared. And two, the timing's going to be different. So by the time these two here make a complete revolution, the light goes across, and this one here is just a little bit out of timing. So what I'm saying is happening is that they're all lining up with each other, and over time the electrons and protons in the entire planet, and possibly even further, are actually in alignment. Now, we all know how strong electromagnetic fields are. Just the free electrons alone can, in some magnets, pinch off a person's finger. So think of the power and the strength that the synchronization of every single electron and every single proton can have. And what I'm saying with this is that this power and this extremely synchronized system is so strong that it can actually control how much electromagnetic field is in the electron. Now, electrons in my model are not only particles, but they are also extremely strong fields that are locked in to place. So when a photon comes by, the electron has a field, the photons have fields, they come in, they add their field strength to the electron and to the proton. Now, field energy, or field strength, I get them confused sometimes, field energy increases the speed. Now, the speed would increase the spin, but the spin's locked in place. So what's happening is it combines with it, and then it's kicked out. And because the lock is so strong, the synchronization is so strong, that it kicks out an exact amount of energy, and that energy is the exact amount of energy that is brought into the system. Now, that being said, what this does is it synchronizes all the photons that are being released from the system. It is synchronized. If we have heat energy in the system, and this heat is releasing energy, all these photons are synchronized, even within the heat release photons. I'm not talking about the lasers, I'm not talking about the ones that have excited states within the end states or the layers. I'm talking about just in the heat systems. So now what we have is we have synchronized electrons crossing a space and hitting a wall. Now, when it hits this wall, every single atom inside has electrons and protons, and every single one of those atoms, even though they're different sizes and made of different structures, they're all synchronized in the same way. And I believe it's a synchronization that's actually, when we look at the models for where electrons are within an atom, I think it's a synchronization that controls those spacings and where those electrons are, the placements of them, because they have to have a certain spin. So from here, what I'm looking at is if we have a more synchronized light, or if we take a synchronized light with an exact wavelength, and we split that wavelength so that it's traveling this way, triangular, then those photons, the spin of the photon, those are both synchronized. So if you add an unsynchronized photon hitting a wall, that if it's reflecting light back, then that anything within that reflection is caused by an antenna effect within the atoms themselves. So we have a photon hitting a wall, but just because it hits a wall in a certain place does not mean that the energy release is going to be in that location, that the energy can hit it, cause a ripple in the atoms, and that ripple going across, and when it hits that pinch point where the synchronization of the atoms are locked in place, then the energy that the photon created is released back, and it's released back in all directions. So what's happening here is we're having an energy system, because they're synchronized here. We have an energy system here, we have an energy system here, we have an energy system here. So this synchronization, so where this energy is being released depends on the synchronization of how the photon gets to the wall in which we're seeing. So when I fire a laser onto a wall, one wall, it hits it in a point, it hits it in a certain area, and that all reflects back onto the second wall, and what we're seeing is dots. And this also works for the double slits, the double slit experiment. It also seems to work for the polarization effect. And like I said, there is a big conundrum in polarization, which is, I wouldn't say it's being denied, it's just not being talked about. And that is that photons do spin, and you have a choice of saying, well, either photons don't spin, or we don't know something about polarization. And seeing as the physics realm is adamant about knowing everything, I'm really expecting them to come out with the next idea that photons don't have any spin. So, going off to the paperwork. Okay, the first thing I need to start on is the basic design for how a photon reacts and moves. The classical way of looking at a photon is through these two aspects of it, and we're working at it as a wave of X, Y, and Z. So we're not really looking at it as a spin. But if we look at the photon here, what's happening is these things here are not actually going back within a plane, they're actually spinning. So if you take a positive and a negative charge on a photon and make it spin around a double helix, and it doesn't really matter if it's a clockwise or counterclockwise spin. If you hit a mirror with one, they actually reverse direction. And this is something that we do know about it. Okay, so so we have one wavelength of this, and each wavelength equals one complete revolution of a photon. So we can calculate each wavelength, or each wavelength having just a slightly different movement. So if you're off even slightly on your wavelength, say a thousandths, so if you're saying 520 nanometers, and you go 0.0001 over a distance, the two photons would actually have different synchronization. Let's see here. So from here I'm wanting to go to antennas, and David Kassler of David Kassler YouTube channel is probably one of the main experts on this, and one of his sort of quotes, this is a long time ago when I heard this, so bear with me. Electrons go into an antenna, but they don't come out. That's saying that, or that's claiming that the electrons are pumped in, and then from here the electrons go to a ground plane. Now, if you look at most antennas, they actually do just about all have a ground plane. Even the antennas on a car or an airplane, they'll have the antenna, but the ground plane is the car or the airplane. Same with walkie-talkies or cell phones. They have antennas in them, but they also have metal around them, which works as a ground plane. So the electrons do have a place to go, and I'm not sure how they're jumping, or actually I don't think anyone does know how they're actually getting from point A to point B. If we're looking at a photon going from point A to point B, then there's a possible synchronization between the two. So from here to here, it would have a particular spin or a particular orientation. The positive and the negative would be hitting the antenna in a certain way. Now, if we look at polarization, it says that if it hits it this direction, that it would excite the positive negative charge to go in either opposite or in directions in this way. An antenna is round, so it has no effect. If the photon hits it this way, then it is taking the positive negative, and what it's doing, the positive charge is stationary, so that means the negative charge is being forced into an acceleration or a new velocity from the photon hit. So what I'm looking at for antennas is that the release time of the photon is within the field. So if I come up here, come down here I should say, we have the antenna, we have a half wavelength here for the antenna. So as we go up, as we go from here to here, the timing of the photon, this line here is being timed by the atoms within it. So we have an atomic timing. We have an atomic timing over here. So these timings here are exact timings on the two antennas. So that this is released synchronized time. It goes a distance and it is received at a synchronized time, but the timing from here to here is the speed of light, so its synchronization is within the wavelength of the photon. So we have a photon released here, it connects, it excites, it gives energy. We have, as we go up, this releases, it times out, then we go up a little more, it releases, times out, and release time, and release timing. And this timing is what actually gives energy and gives a synchronized acceleration to the electrons that are within this metal antenna. And here I'm just saying the energy of a photon, the energy of the photon, that means the wavelength or the frequency of the photon, pretty much the same thing. It sets the electron, it sets the acceleration rate of the electron. So a higher energy photon would have a higher acceleration for the electron, and or deceleration for if it's acceleration for if it's accelerating, or deceleration if it's coming to the end of the antenna. So polarization, switching gears here, going to polarization. If we have the timing of it being set at this particular place, so if this antenna is vertical here, standing straight up, and then we have another antenna between two trees, so we have another antenna this direction, the polarization would be different, and we would not receive a signal from sightline antennas. This antenna here would not receive a signal here. It would have to be repolarized, and there's nothing in the atmosphere that really repolarizes it, so we don't get a signal on that. So now let's look at what doesn't polarize, and that's if you go out to a lake and when it's raining, and you look at the waves created in a lake when it rains. Each one of these raindrops is not synchronized. There's no synchronization to a raindrop. They are completely randomized. And if you look at it, you'll notice that these raindrops, they do not create wave patterns within the lake. You'll see waves from the individual raindrops hitting it go through the lake, but there is no synchronization within it that actually creates waves within the lake. It pretty much stays perfectly flat. The wind will do it, and it'll do it according to how wind makes eddy currents. But within raindrops, this polarization effect, this wave synchronization effect, doesn't occur. One wave, it hits it, it adds to it, and then it dissipates and it keeps going. So, getting back to polarization, so if we have one going one direction and you turn the other one at 90 degrees of itself, you lose some light going through the first one, but the second one has 100% absorption rate, as in nothing passes it. So where the energy goes to is that the secret of making a polarizer, and it is just that, it is a big secret. I've not been able to find anyone to actually show me how, other than to say that there's metal strands in here and that there's actually just multiple micro antennas, and this is being polarized. Now if you look at the military antennas, you'll see a lot of military antennas will have the same things up on ships, and they'll have one going up and down and another one going side to side, and they can use the exact same frequency and send two different signals from one ship to the other with this type of antenna system. So polarization does have an effect. It has an effect with invisible light. It has an effect on basically every frequency of light in the spectrum. So going back to this polarization and how it works, and what I'm speculating, and this is again pure speculation, I'm speculating that the timing of light passing through here hits an antenna. The photons that are collected by the polarizer create a wave function within the metal filament, and it just vibrates back and forth until it's turned into heat. The light that does not match the electromagnetic frequency of the filament, so we have a photon hitting it this way and being absorbed, but if it hits it lined up instead of this direction but lined up at a 90-degree angle, the filament can't absorb it, or it cannot hold it. So it hits it, it combines with the filament, and then it is released, and it has the same energy, and energy is conserved, so it has the exact same direction, and it just passes through that antenna. So we have pass through. We turn it at a 45-degree angle again, and this 45-degree angle is going to take all of it, and it's going to turn it. So it absorbs it, the pass through flips it and turns it, and it turns it in this direction. So now, and I'm not talking about the spin of the electron, I'm talking about when the electron hits it. So this filament has a vibrational frequency. If it doesn't, so if one hits it, it creates a vibration through it. If another one hits it, it's either in synchronization with that vibration or it's not. If it's in synchronization, it's absorbed. If it's not in synchronization, then it passes through. So we have them now at 45-degree angle. So if we're hitting them this direction, if all the photons are hitting at a 45, some of them are going to hit within that frequency and some are going to pass through. And when they do pass through, they're going to pass through at the synchronization 45-degree angle of the the synchronization of the photons passing through will be a 45-degree angle of the first one. So from here we're hitting another one that's going this direction. So we're, again, all these are synchronized at a 45-degree angle. That is, this one hits here, this one hits here, this one hits here, and they're synchronized this way. So we then have a synchronization within the filaments within the polarizer, and that synchronization is either grabbing the photon and absorbing it and turning it into heat, or it is grabbing it, collecting it, and then kicking it out with the same directional momentum that it had in the first place. Going to polarized, or I should say circular polarization, we have antennas that come out and then curlicue, and then we have the exact same curlicue coming on the other side. So this thing's creating light, and I have no idea how it's doing it. I'm thinking it's hitting the ground plane and then going from ground plane to ground plane. So it's hitting this ground plane, kicking off electrons. Those electrons are hitting the antenna in a certain way that it creates a magnetic field, or it's hitting it and creating a magnetic field. I have no clue as to how this is working. That's going back to the regular antenna where the electrons are being forced into the antenna. And in theory, according to Dave Kassler and most of the people that work with radios, the pros at radios say that the electron is actually passing through the antenna to the ground plane. The issue is that nobody's ever put a cloud chamber here, and that's something that really needs to be done. One cloud chamber could tell us how the motions of the electrons are actually going from the antenna to the ground plane. That's a piece of science that I have never seen yet. So, moving on. The timing again. So we have a photon. We have a positive and a negative charge, and it is spinning either in this direction or that direction. And when it hits an electron and proton, that energy is being absorbed. The energy turns into velocity. The velocity is controlled by synchronization of the electrons and protons all around it, and because it is trapped within that synchronization, it absorbs it and it immediately kicks out. Energy is conserved, and the kick out is in the same direction in which it came from. If the energy absorption is of a different form, then it is reflected. If the synchronization matches with the free electrons in the pattern, then the free electrons can actually, the energy of the free electrons can actually be accelerated in a particular direction. And that acceleration causes what we know as electricity. So, recapping what I said earlier, big ouch, and this is basically speculation to the 12th power. This is going way out on a limb here, and it sounds right. So we're saying protons have their own resonant frequency, neutrons have their own resonance frequency, electrons have their own resonant frequency, and these three here are the subatomic, and they have this one here would go to the particle zoo, as that we now see, and saying that it splits apart all positive, negative, and neutral particles having different frequencies, and it's this frequency that creates the creates the sink that the electron sinks into, or that the proton sinks into its own energy state. So anytime you have an electron with an excited state, it's where an electron has more energy than another electron, then that electron is in motion, or it's in an unstable state. So I'm saying there's a reason why we have electron positive proton split-offs, not proton, electron positron. The positrons would be unstable. And that stability, eventually, it either reconnects within an electron and goes back to a photon, or it leaves an electron out and it creates a stable positive waveform of its own type. We have the free electrons, which we generally refer to as electricity, as the creation of electromagnetic frequencies, but that's the electromagnetic frequencies in which we can work with. All other electromagnetic frequencies are things that they're pretty much locked into. So now, going back to the one I skipped, atoms have their own resonance electron-proton frequency. That's the frequency where the electron travels around the proton. So I'm pulling this one out, I'm setting it aside, and I'm dealing only with this one. This is the story I had about cast iron. And now we're back to the double slit experiment, where we're dealing again with atoms having their own resonant frequency. That's the spin frequency of electron-proton. This also states that atoms, and this is a hard one to grasp, that atoms all have spin, so if you stack the atoms, and it doesn't matter if they're in the gas, solid, or liquid state, all of them would have pretty much the same frequency. This frequency would be locked in place. So, going back to the double slit experiment, all atoms pass, reflect, or absorb photons. So the atoms themselves do one of these three things, and I'm speculating that all atoms work like antennas and or polarizers depending on wavelengths. But again, polarizers are antennas. So it is this synchronization that I'm talking about with the double slit experiment, and this is the reason why I am willing to accept the idea that the double slit experiment, that the interference is not coming from the double slits, but it's coming from what is, whether it be the wall, whether it be photographic paper, photographic film, or in the case in modern day, a digital backing on a camera. And that's pretty much the end of this one. It was a long one. Sorry about the length. And I'll see you on the next video.